Hello, everyone, and welcome back to Tactical Horizon, your destination for in-depth analysis of global defense, military technology, and geopolitical developments. Today, we're taking a close look at one of the most important technologies that will shape India's future air power. Not a new fighter aircraft or a new missile, but the engine that powers them. For decades, India has relied on imported jet engines from the United States, France, and Russia. But that may soon change. A new vision is emerging to develop an entire family of indigenous fighter engines ranging from 90 kilonewtons to 140 kilonewtons of thrust. If successful, these engines could power everything from upgraded Tejas fighters and advanced unmanned combat aircraft to the fifth-generation AMCA and even India's future sixth-generation combat aircraft. We'll also examine India's growing partnerships with Rolls-Royce, France's Safran, and discuss where Russian engine technologies such as the new 177S fit into the bigger picture. India's indigenous fighter jet engine roadmap, from Kaveri 2.0 to sixth-generation power plants. Introduction. For more than 4 decades, India has pursued the goal of developing an indigenous military jet engine. While the Kaveri program laid the technological foundation, it fell short of producing an operational power plant for the Tejas fighter. Today, however, India appears to be entering a new era. The focus has shifted from developing a single engine to building an entire family of indigenous turbofan engines ranging from 90 kilonewtons to 140 kilonewtons of thrust, capable of powering everything from upgraded Tejas fighters and unmanned combat aircraft to the Advanced Medium Combat Aircraft, AMCA, and eventually India's sixth-generation combat aircraft. This modular approach represents one of the most ambitious aerospace programs ever undertaken by India and could fundamentally transform the country's defense industrial ecosystem. The concept has been publicly advocated by former GTRE officials and aligns with broader discussions on India's future propulsion strategy. Why India needs an indigenous engine. Today, almost every frontline Indian combat aircraft depends on imported engines. Tejas Mark 1/Mark 1 A uses the GEF 404. Tejas Mark II will initially use the GEF 414. AMCA Mark 1 is also expected to begin with the GEF 414. Su-30MK uses Russian AL-31 FP engine. Rafale uses French M88 engines. Although India has mastered aircraft design, radar technology, weapons integration, and mission computers, fighter engines remain the last major strategic dependency. Jet engines are among the most difficult engineering systems ever developed, requiring expertise in single crystal turbine blades, high-temperature metallurgy, ceramic coatings, compressor aerodynamics, FADEC software, precision manufacturing, advanced cooling technologies. Only a handful of countries possess complete indigenous fighter engine capabilities. A modular engine family. Rather than designing separate engines for every aircraft, former GTRE scientists have proposed a scalable engine architecture based around a common core. The proposed roadmap includes 90 kilonewton engine applications, Tejas, Mark 1 a replacement, future Tejas upgrades, UCAVs, HALE combat drones. This engine would replace the imported GEF 404 while producing approximately 90 kilonewtons, exceeding the F404-I N2O's roughly 84 kilonewtons afterburning thrust. It would also provide a common propulsion solution for future unmanned combat aircraft. When 100 kilonewton engine applications, Tejas Mark II midlife upgrade, future light fighter programs. Instead of designing a completely different engine, engineers propose a detuned version of the 120 kilonewton engine using the same core architecture. Advantages include common spare parts, lower manufacturing costs, reduced maintenance complexity, shared logistics, simplified pilot conversion, lower lifecycle costs. By the 2040s, when the Tejas Mark II reaches midlife upgrade, an indigenous 100 kilonewton engine could replace imported engines with minimal redesign. 120 kilonewton engine. The centerpiece of India's future propulsion program is the 120 kilonewton class engine. Applications include AMCA Mark II, twin-engine UCAVs, future naval fighters. This engine represents the technological leap India has pursued since the original Kaveri program and is intended to incorporate advanced hot section materials, digital controls, and high-performance core technologies. Current national plans center on a jointly developed 120 kilonewton class engine for the AMCA program. 140 kilonewton engine. The final stage would evolve the same core into a 140 kilonewton class power plant. Potential applications: sixth-generation fighters, heavy UCAVs, loyal wingman aircraft, future strategic strike aircraft. Higher thrust would support larger internal fuel loads, increased payload, directed energy systems, advanced electronic warfare, optional manned operations, supercruise with heavier combat loads. Partnership with Rolls-Royce. One of the most significant recent developments has been the proposal from Rolls-Royce to co-develop a new generation of combat jet engines with India. According to public statements and recent reporting, Rolls-Royce has proposed co-development of a 120 kilonewton class engine, significant technology transfer, Indian intellectual property participation, local manufacturing, long-term industrial partnership supporting India's indigenous propulsion ambitions. If fully realized, this would represent one of the most comprehensive technology collaborations India has received in military aero engines. Rolls-Royce also envisions growing this collaboration beyond a single engine into a broader family of military propulsion systems, an approach that closely mirrors the scalable roadmap proposed by former GTRE officials. The French partnership, alongside the British proposal, Safran of France has emerged as India's selected strategic partner for co-developing the 120 kilonewton class engine intended for later AMCA variants. Public announcements indicate the program aims for extensive technology transfer and Indian manufacturing under GTRE leadership. The technologies expected to benefit include single crystal blade manufacturing, high-pressure turbine design, advanced combustors, thermal barrier coatings, digital engine control systems. This collaboration is widely viewed as the fastest route toward an operational indigenous high-thrust fighter engine. Russian cooperation. The 177S engine. Russia remains an important propulsion partner through its experience with high-thrust fighter engines. One of the newest developments is the Izdeliye 177S engine. The 177S is reported to combine technologies from the newer AL-51, formerly Izdeliye 30, program with the proven AL-41 family. Publicly available information indicates it is designed to provide approximately 14,500 kilograms force, around 142 kilonewtons of afterburning thrust, improved fuel efficiency, longer service life, compatibility with aircraft currently powered by older AL-31 family engines. Commonality reduces costs. A modular engine family offers major operational advantages. Instead of maintaining several unrelated engine types, the Indian Air Force could standardize training, spare parts, maintenance equipment, repair depots, software, FADEC systems. This reduces operating costs while improving aircraft availability. Challenges ahead. Developing a modern fighter engine remains one of the most demanding engineering tasks. India still faces challenges in advanced turbine metallurgy, high-pressure compressor efficiency, thermal management, long-life turbine blades, variable cycle engine technology, extensive endurance and flight testing. The original Kaveri program demonstrated how difficult these technologies are to master. Nevertheless, it also created the industrial and scientific base that today's programs can build upon. Strategic outlook. India's propulsion roadmap now appears to be evolving from a single-engine project into a long-term national capability. If successful, the roadmap could unfold as follows. Combined with strategic partnerships, domestic manufacturing, and decades of accumulated GTRE experience, this roadmap could finally give India what it has pursued since the 1980s. A fully indigenous family of modern fighter jet engines capable of powering multiple generations of combat aircraft. The future of India's aerospace industry will depend as much on propulsion as on stealth, sensors, or weapons. Whether through indigenous innovation, collaboration with partners such as Rolls-Royce in Safran, or lessons learned from Russian high-thrust engine development like the 177S, India is positioning itself to close one of the last major gaps in its defense technology base. If you enjoyed this deep dive into India's future fighter engine roadmap, don't forget to like this video, subscribe to Tactical Horizon, and turn on notifications so you never miss our latest defense and military technology analysis. I'd also like to hear your thoughts. Do you believe India can successfully develop an indigenous family of fighter jet engines? Or will international partnerships remain essential? Share your views in the comments below. Thank you for watching, and I'll see you in the next episode of Tactical Hori.